Two lessons, we learned about tangent, and we learned that the ratio for tangent, TOA, was that tan of any angle is the opposite side divided by the adjacent side. Today, we're going to find out about SO and CA. And together we make this fancy word SOHCAHTOA to help us remember all of the ratios. So yes, we could get away with just tangent, because if I had this, for example, right, if I told you this was 27 degrees and this was 6, and I wanted to find x, you could use tangent, and if I wrote tangent of 27 degrees, tangent, TOA, is opposite over adjacent, so I could write the opposite here being, I guess I'll use the letter y, over 6, and then you could use your algebra to find out what y is. You'd have to multiply both sides by 6, and then you would get a number of y. And because your calculator has all the tangents memorized, I can go 6 times tangent of 27 and push enter, and it tells me that y would be 3.06. And then do you see that if you had those two, you could find the third one by doing a squared plus b squared equals c squared. So if I did 6 squared plus 3.06, wow, that's terrible looking, squared, that would equal x squared. And if I do that on my calculator, so 3.057 squared plus 6 squared equals, and I square root it, square root my answer. Again, notice that I used answers throughout, so I didn't round early. I would find out that x is 6.73. But our calculator also has a sine button and a cosine button. So we could solve for x using 6.73, but we're going to find out that sine and cosine also have definitions. What do you think the A stands for and the H stands for in the cosine one? Adjacent and hypotenuse. So if that's true, that would mean cos of an angle is the adjacent side over the hypotenuse. Can you see in our question, we knew 27, we knew the 6, and we wanted to find the hypotenuse. So if I wrote that out, my angle was 27. My adjacent side was 6. My hypotenuse is x. Do you remember what we did when we solved for tan when x was on the bottom? We had to first multiply both sides by x to move it off of the bottom. That would simplify it off of the bottom there, but now we would get x times cos of 27 equals 6, and to get x by itself, we would have to divide. Do you remember that with tan? So now, if this is true, that cos is the adjacent over hypotenuse, which we guessed from up there, if I type this into my calculator, go to my calculator, 6 divided by cos of 27, that supposedly is x. Do you see that we already figured out from this one that x was 6.73 by doing tangent and then a squared plus b squared equals c squared? Check this out. Now I push enter. I get exactly the same answer with cosine. So these are our new definitions. The cosine would just remove a step. And sine sometimes would remove a step. So now you could do it with tangent, but sometimes it would take 2 steps. If you now have sine and cosine, you can do any question in just 1 step. When would you use which one is going to be the biggest question. So for example, if I drew this out, you would have to say, what do I know? I know the hypotenuse, and I know this angle. What do I want to find? I want to find which one? The x. Would I say that that's the opposite of 32 or the adjacent to 32? That would be the opposite to 32. So then, when asking which one should I use, I think of the word SOHCAHTOA, because the SOHCAHTOA word is easy to say, and it has all 3 definitions built into it. Which of your SOHCAHTOA ones uses the opposite and the hypotenuse? The SO. The SO. So then I would write out, so this is asking which one would I use? Like they'll all work, but sine will only be 1 step. Cosine and tangent would take you 2 steps to figure it out. So I would write out that sine of 32 degrees is equal to opposite over hypotenuse. Multiply both sides by 7. Type it into my calculator. 7 times sine of 32. Enter 3.71. And I find it directly. Okay? So you have to analyze what you want to find and what you're given to figure out which one will work the best. They will all work, but some of them, if you decided to use cosine or tangent, well, this one you actually can't even use tangent because you don't know both the opposite or adjacent. Tangent wouldn't even be possible in this one. But you could use cosine, but cosine would find the adjacent side, which you don't need yet. And once you have the adjacent side, you could do a squared plus b squared equals c squared, but why not find something out directly? So once we have all 3, SOHCAHTOA, we can always find things out directly. Oh, yes. This is, here, want to see an example of a clinometer? Nice eraser as a weight. Is that eraser? No, it's little tiny tapes. Okay, sorry. So got the protractor on there, got the straw, so when you look through, it hangs down. So, perfect. So very similar to what we did in our assignment at the beginning of class today. Here it says determine sine of G and cos of G. So here's my angle G right here. If I want to write what sine of G is, I would have to know which is my opposite, which is my adjacent, which is my hypotenuse. So if I'm looking at the angle G, well, does it make sense? You can always label your hypotenuse. Hypotenuse is always the longest side. Does it make sense that your opposite and adjacent change depending on which one you're talking about? If I'm talking about G, then this is my opposite. But if I was talking about J, then 15 would be my opposite. If I'm talking about G, 8 is my opposite and 15 is my adjacent. So if I want to find sine of G, I think about SOHCAHTOA. Sine is opposite over hypotenuse, which is my opposite side. That's 8. That would be little g. which is my adjacent side, little j, that would be 15. To the nearest hundredth. To the nearest hundredth would be, oh yes, thank you. Oh my goodness. Opposite over hypotenuse. See, I would like to say that I did that on purpose to see if you were paying attention, but I didn't. It was just like honest mistake. Okay, honest mistake there. So we go to our calculator. 8 divided by 17 is 0.47. So the ratio as a decimal is 0.47. The ratio as a fraction is 8 over 17. Okay? Common mistake that students make is they then find out what angle G is. We don't have to find angle G. The question asked to find sine of G. Super easy. Just write the, well, opposite over hypotenuse. Unless you screw up and write the adjacent side. Next, finding cos of G. Think about SOHCAHTOA. Cos is the adjacent over the hypotenuse. The adjacent side is 15. The hypotenuse is 17. Go to my calculator. 15 divided by 17, 0.88. That's rounded to the nearest hundredth. Now, technically, I prefer the fraction because the fraction is exact. The decimal, you had to round it. Rounding things can cause your final answer to go off if you had to do more math. So when it's asking for sine G and cos G, it's just looking for you to do the opposite side divided by hypotenuse or adjacent side divided by hypotenuse. That's all. Do you remember how you found the angle with tangent? For example, I could write out, if I wanted to, tan of angle G is equal to opposite over adjacent. Do you remember what we did to find angle G with tangent? We used our calculator. We did it two ways. We did it the long way. The long way looked like this. 8 divided by 15 is 0.533. Okay, we'll start off with Judah. Give me a random angle. 17. Is he right? No, 0.305. Okay, so then Tyler, give me another angle. 25. Is he closer? Yes. Do you remember when we did this? And then, what should you try next? 31. Ooh, too much. 27. Not enough. 28. Ooh, closer. 29. Oh, that's pretty close. But now I don't even see the number anymore. I have to do 8 divided by 50. It's supposed to be 533. Oh, 20, 28.2. I think that's going to be too low. 28.7. Okay, so what's the problem with this? We are getting closer. It's going to take forever to get exact. Okay? So do we remember what we did instead? We went and said our calculator has also all the ratios memorized. So if I go tan inverse and said I originally had 8 divided by 15, it was 28.072486. Oh, we were so close. No, we weren't. So we could find G by doing tan inverse of 8 divided by 15. Do you think we could find G using sine? Above your sine button, notice there's a sine inverse. Watch this. If I do sine inverse of 8 divided by 17, because that was my sine ratio, 28.07. If I do cos inverse of 15 divided by 17, they have all of them memorized. They know that if I give you one of the ratios, I can find the angle using my calculator. Use a calculator to determine and draw a picture to show what it means. So calculator to determine sine of 30. Take out your calculator. Make sure that if you type in sine of 30, you get 0.5. Some calculators, you have to be in degrees. Some calculators are in radians. So if you're not getting 0.5, you're not. Perfect. So hit the mode button, and you're in radians. So we go over to degrees and push enter. And now type sine of 30. Boom. Anybody else not getting 0.5? Okay. So now, draw a picture. Well, this is trigonometry, so it involves right-angled triangles. If I draw a right-angled triangle and I label an angle as 30 degrees, what does the 0.5 mean? Okay? I'm going to draw a triangle. You have to draw a different one than I draw. Okay? You're not allowed to draw the same one that I draw. What does the 0.5 mean? Well, sine is opposite over hypotenuse. So this one divided by this one has to be 0.5. I could pick 1 and 2. You're not allowed to use 1 and 2. You can use 2 and 4. Oh. Okay, 2 and 4 has been used up. Oh. Okay. Try to pick one somebody else hasn't used. You could use 10 and 20. As long as the opposite, when you divide it by the hypotenuse, you get a half. It doesn't matter how big or how small your triangle is. That will always work if it's 30 degrees. The 0.5 told us that this side divided by this side always is a half. So let's do cos. What happens when we do cos of 15? Cos of 15, 0.9659, 0.96, wow, I can't even remember, 59. So if I draw a triangle with 15 degrees and a 90 degrees, cosine I'm going to put can you make this into a fraction? What is it about? Approximately, right? I could go to 2 decimal places. That would be my hundredths. Can you see that's approximately 96 over 100? Well, technically, it's probably closer to 97 over 100. Or you could do 966 over 1,000. If it's approximately 97 over 100, drawing my triangle, I would say my adjacent side is 97. My hypotenuse is 100. Oh. Does that make sense now from the, because that, I tried to, instead of trying to re-explain the first example, we did a second example and hopefully you would see it. What would this side be as an example? Can you see that if I did sine of 15 on my calculator, and I did sine of 15 on my calculator, and I get 0.2588. What is that approximately over 100? 26. I already had 100 as my hypotenuse. That means this side would be approximately 26. Is this perfect? No, because we rounded. In fact, if you check it out, 26 squared plus 97 squared is 1,085. What's 100 squared? 10,000. See how they're close, but off a little bit? Because we rounded. Okay? We gave, and that's why I wrote approximation signs, because it's not perfect. I could go 966 over 1,000. It would be closer. Okay? But what the ratios give us is an idea of what the triangle looks like. And it gives us an idea of what we could use as an approximation for hypotenuses, opposite sides, and adjacent. Where it's really powerful is when you know two things on a right triangle, you can find everything. This question is just asking for angle K and angle M. Let's do angle K first. So if I want to find angle K, again, I have to decide which one would be fastest, sine, cosine, or tangent. Always label your hypotenuse. Do your opposite and adjacent in your head. So your hypotenuse, agreed, is always going to be the 8. The reason I say do opposite and adjacent in your head is because they're going to change depending on which angle you look at, right? The number 3 is opposite for K, but adjacent for M. So I don't really want to write opposite here because it's not always the opposite. So this one, okay, I want to find K. What should I use? SOHCAHTOA. You should use sine. Why should you use sine? Because you know the opposite of K and you know the hypotenuse. So you can write the ratio that sine of K is the opposite side over the hypotenuse. Then your calculator has it built in. Instead of guessing and checking, to undo the sine, we do sine inverse. Mathematicians, you know how you, like technically, you know how you get rid of adding? You subtract something on both sides. You get rid of multiplying by dividing on both sides. You get rid of squaring by square rooting both sides. You get rid of the sine by sine inversing both sides. But mathematicians don't like to write, it's like, oh, this is too much to write on both sides. You could and then go cancel, cancel, and just get this. But you'll find that mathematicians, like, that's so much to write. We don't like writing essays or even words. So we just write K is the sine inverse. Go to our calculator, type in sine inverse of 3 divided by 8, 22.02. To the nearest tenth of a degree, how would I write to the nearest tenth of a degree? 22.0. I know you feel like, can I just write 22? Technically, that's what it is, but more accurate is 22.0. How can you find angle M? Okay, I hear two different ways. Yes, both of those ways will work. Angle M, somebody said just go 90 minus 22. Because there's 180 in the whole circle. One of them's a 90, which leaves me with 90. The other one's a 22. It's going to equal 68 degrees. To the nearest tenth, 68.0. Perfect, thank you. Okay. But I heard somebody else say, ooh, we could use cos. Cos of angle M is the adjacent side, which is the 3, and the hypotenuse is 8. We have all of our ratios memorized in our calculator. So we can get rid of the cos by doing cos inverse on both sides. We could type it into our calculator. Cos inverse of 3 divided by 8. 67.97 rounded to the nearest tenth would change that 9 to a 0 and that to a 1. .0 degrees. Which is easier mental math? Or probably the 180 minus, right? That's a little bit quicker. But it's nice to see that both of them would work. At a certain time, a float plane is 300 meters above the water and 430 meters from an observer. So, we have to draw a picture of this. We've got our float plane. Ooh. Oh, I like it. Looks like a bunny plane. Mm. Looks like a fish eating another tiny fish. Okay, there's my plane. Does it make sense that I would be able to draw a height here and label that height as 300 meters above the water? Then there is an observer. Here is my little observer. Oh, wait for it. Yes. Okay, there's my little observer. Why is he on the ground? No, the water ends right here. There we go. Maybe he's on a boat. Where am I going to label the 430 meters? Is the 430 meters here, or is the 430 meters here? There, because this would be the distance away. Determine the angle of elevation. Do we remember which one was the angle of elevation? This one right here. So angle of elevation is from horizontal looking up. Do you remember what the word was for angle of looking down? Angle of depression. So angle of elevation is horizontal looking up. Angle of depression, horizontal looking down. So we want to find that, and I'm going to use the letter theta. Do you remember that was called theta? Okay. So, katoa, which one should we use? I can label the hypotenuse right away because that never changes. Here's my 90 degrees. I should use the so I can write out that sine of theta is 300 over 430. A lot of students, I can tell you that for many students in grade 10, trigonometry is their favorite unit. Yeah, because it is like, it's not that bad once you know like the definition, SOHCAHTOA. Just have to know how to label opposite and hypotenuse. So how do I get rid of the sine? I sine inverse both sides. My calculator has that memorized. Sine inverse of 300 divided by 430. 44.24. It says to the nearest degree, 44 degrees. Not bad at all. Okay, we will end there.